Exam 1 load tracing. Exam 1 is completely online. Exam will open on Tuesday, February 11, 8 a.m., and it will close on Tuesday, February 11, 11:59 p.m. So you have from 8 a.m. until 11:59 p.m. to complete your exam. Exam duration is 3 hours. So make sure that you start early enough so that you have the whole 3 hour to work on your exam. And you will only have one attempt. There are 11 questions, one true and false question, one short answer question, and there are 9 problems. Problems will be similar to the problem that we solved during our class and the examples that you had to complete for your quiz and homework assignments. So exam 1 is available on As You Learn page, and you will have access to the exam using this link on Tuesday, February 11. If you would like to review the exam later, keep your worksheets organized and number the questions in your worksheet. So in order to get prepared for the exam, you need to review load tracing lectures and load tracing examples. One of the first things that we talked about was the use of equations of equilibrium. And we went over 3 simple examples on how to use equations of equilibrium to solve for reactions. So the example that you see here is a simply supported beam with uniform load. Since we have a symmetric system, reactions are equal to each other and they're equal to load times length of beam divided by 2. This is another example that we went over it during our class. And again, another example how to use equations of equilibrium to solve for reactions. So here, the system that we have is not symmetric. And we need to use equations of equilibrium. And we need to use sigma m around point A is equal to 0. This is point A. So we have a uniformly distributed load. We will replace that with the equivalent resultant. So the resultant of this uniformly distributed load is equal to load times total length, which is 13 feet. And it's placed at the midpoint of the total length of beam. So the total length is 13 feet and it's placed at the midpoint, which is 6.5 feet. Now, if we want to solve For reaction at point B, we can actually write down the formula for sum of moments around point A is equal to 0. Here, the resultant has a clockwise moment, so we're going to use a negative sign here. And here we will have a counterclockwise moment, so we're going to use a positive sign. So we have minus 13,000 times 6.5 plus reaction of point B times 10 feet. Is equal to 0. And we get reaction at point B is equal to 13,000 times 6.5 divided by 10. And then when we have reaction at point B, now we can solve for reaction at point A. So we have the downward load here, the resultant pushing the beam downward. So we have minus 13,000 pounds plus reaction at point B upward and reaction at point A is equal to 0. So make sure you know how to use equations of equilibrium to solve for reactions. And then we went over 6 different examples. This was example number 1. So for this example, we wanted to calculate the ground reactions. You need to calculate the total live load and dead load that we have multiplied by tributary width for loads on each beam. For example, for loads on beam A, tributary width is half of distance between A and B, which will be 3 feet. So our total dead load and live load times tributary width gives us the load that we have or transferred from the area to the beams. Then you need to draw free body diagram, 16 feet and 12 feet, and calculate the reactions. This is A1, A2, and A3. Pay attention to the information provided in the question, and also pay attention to what the question is asking for. So then we have these columns, and we have the column reaction. So the load transferred to the column, we refer to these as column reactions. And then when you add dead load of column, we can have ground reaction. So this is foundation or ground reaction, and the load transferred from the beam to the column is our column reaction. We need to add column weight to column reaction to get ground or foundation reaction. For the next example, we have started the same way as the previous example. So we had to calculate again the total dead load and live load. And load path is from area to beam to girder. So we needed to calculate or find tributary width for our beam and multiply dead load and live load by tributary width of load on beam B1. Then we did the FBD for beam B1 and calculated the reactions. The reactions are then transferred to girder G1. So next we had to do FBD of girder, which is here. And we had 1, 2, 3 point loads from beams attached to the girder. Remember that you need to add dead load of girder in your calculation. And then we calculated the end reactions. For example number 3, again, we have started by calculating the total live load and dead load. And the load path is again the area load or total dead load and live load to beam to girder. So we calculated the dead load and live load, total dead load and live load, and multiplied that number by tributary width of load for beam B1. Then we did the same thing for B2, and then we repeated the process for beam B3. And then we did FBD of B1 and beam B2. For beam B1 and beam B2, we have a uniformly distributed load. And it's a simply supported beam, so we can calculate the reactions. But for beam B3, we have two different sections. One section has a tributary width twice the section that has an opening on one side. So when we do FBD of beam B3, we have two sections with two different load magnitudes. And since this is not symmetric, for this section you have to use sigma MA is equal to 0 and sigma Fy is equal to 0 to solve for the reactions. And when we got to the girder, again, we had the load transferred from beams to the girder, where beams are connected to the girder and not to the column. So then we did FBD of girder. Where we had 2-point loads transferred from beam B2 and beam B3, and also dead load of girder. This is also not a symmetric system, so we have to use sigma M is equal to 0 and sigma Fy is equal to 0. One more thing that I want to mention is that in this question, when it's talking about opening side reaction, the reaction on this side is opening side reaction, and reaction at this point is the girder side reaction. In example number 4, we looked at a sloped roof. So here, when we have a sloped roof, pay attention that a snow load is provided on the horizontal projection. So it's already on the horizontal projection of a rafter, for example. But when you have dead load, it's along the rafter. It means that it's on the slope. So it's like this. And it needs to be adjusted to the horizontal projection of rafter. And in order to do that, you need to pay attention to the roof pitch. So for example, if roof pitch is 5 to 12, that means that this side is 13. So if we have 100 PLF here, the adjusted load is 100 PLF times 13 divided by 12. So for this example, we multiplied a snow load by tributary width of load on a rafter. Then we did the same thing. But we also had to multiply load by the adjustment factor to adjust dead load from along the rafter to the horizontal projection. And then we added these two together. And that provided us with the load on a single rafter. Then we calculated these reactions. On one side, the reactions are transferred to the bearing wall, and on the other side, they are transferred to the beam. Rafters are placed at 24 inches on center. So we calculated the load in pounds per 24 inches or 2 feet. And then we divided both of these numbers. So we divide this by 12 and convert this to 2 feet. And then we divided both sides by 2 to have the loads in PLF. Then we did FBD of beam and calculated column reactions and then ground reactions. Example number 5. For the examples that are longer, this is really important that you pay attention to the information provided in the question. There won't be a question that asks you to go over all the steps. So in order to avoid that, the questions are providing you with some information and asking you to calculate a reaction. So make sure that you read the question carefully, see what is provided and what is asked from you. In example number 5, we have started again by calculating live load and dead load, and then we multiplied that number by tributary width of load on an interior beam, and then we did the whole thing for an exterior beam. So here also the load path was from area to beam to girder to posts. So we had a tributary width for an interior beam, and then we did the calculation for an exterior beam. So these are the exterior beams. And then we also have the interior beams. And then we were able to calculate the amount of load transferred from each one of these beams to the girder supporting beams. So we did FBD for interior beam, FBD for exterior beam. We calculated the load transferred from interior and exterior beams to the 4x10 girders. And then we did FBD of girders. We also need to include dead load of girder, and we calculated the post reactions. So we have post A, post B, and post C. And lastly, we looked at the posts. We have the load applied. We are looking for the minimum required width, and the cross section of the footing is actually a square with an area of x to the power of 2. So we said that load applied divided by area of footing should be equal or less than net allowable bearing capacity. And this is what we get from geotechnical investigation. So if you rearrange, this should be higher than load applied divided by net allowable bearing capacity. The last example was a simple wood framed structure, and we started from roof looking at rafters. So we did FBD of rafters. Rafters are supported by the bearing wall and beam. So we did FBD of bearing wall, FBD of ridge beam, and then also FBD of column supporting the beam. So the load from here goes to continuous foundation, and the load from here goes to a spread footing. Then we also looked at the flooring system. So we did FBD of joists and calculated the load transferred from floor to each joist, and the load calculated the load transferred from joists to floor beam, and also the load that goes from joist to continuous footing. And from here it goes to a spread footing. So we add these two together and these two together to find the total load transferred to the continuous footing and a spread footing. And then we were able to design our continuous footing and also our spread footing. So again, the best way to prepare for exam number 1 is to review the examples that we covered during our class in our lectures and the examples that you had to complete for your quiz and homework assignments.